Hi, welcome to a podcast about osmosis. First, to understand osmosis, you must understand diffusion. Diffusion is when a set of particles move down a concentration gradient. A concentration gradient occurs when an unequal distribution of molecules is across a membrane. Okay, here's an example of diffusion. If you just take a simple balloon that's filled with air, you know that there is more molecules of air inside of the balloon than outside. That causes a concentration gradient because of the unequal distribution of air molecules. Okay, so if I let go of the tip of this balloon, diffusion will occur, which means that the air molecules will move from high concentration from inside the balloon to low concentration just outside of the balloon, like this. The diffusion of water is known as osmosis. Osmosis usually occurs when a semi-permeable membrane is present. First, let me explain to you what a semi-permeable membrane is. First of all, a membrane is something that encloses a body. First, let me draw some random object, and then I will construct a membrane around that object. That's not a good one. Okay, that's good, like that. Okay, a semi-permeable membrane is a membrane that will allow some things to enter and some things to not enter. For example, let's say that it will allow these small ovals to enter. These small ovals can enter because they fit through the spaces, but it does not want these squares to enter. So it makes the openings in the membrane just big enough so that the ovals can pass through, but the squares are not able to. That is a concept of semi-permeable membrane. So before we move on any further, I must explain two terms known as solute and solvent, and a solution. Okay, a solution is basically a mixture of a solute and a solvent. And then, first, to create a solution, a solute must be dissolved into a solvent. So, in most cases, well, not in most, but in many cases, water is a solvent. So let's take a simple sugar solution here. Here's some water, right here, plain water. And let's say to add to the water, you want to add a little bit of sugar. So let's just make some sugar here. Let's make it white. That's some sugar molecules here. Okay, so in this case, the water would be the solvent because it is the thing that you are dissolving the sugar in. And since the sugar is being dissolved in the water, it's known as a solute. Okay, now let's see how this all pertains to osmosis. Okay, let's zoom out. Right. So let's zoom into this system here. So let's take this container, and this container has a semi-permeable membrane right here. And just like the earlier version, we'll use water molecules and urea molecules as an example. Okay, last time I showed you that the water molecules could pass through and the urea molecules couldn't because of the size of the molecule. But there's also another reason why it couldn't pass through. It's because of the polarity of the molecules. So in this case, let's create a different object, and we'll take it as just, let's say, some protein, because proteins are polar. So first, let's add water molecules to one side. Let's say 5 on this side, 5 on this side. Okay, so Since the concentrations of water are equal, the system is at equilibrium and no diffusion needs to occur. Okay, let's say that we add some protein to one side. Let's say the 2 molecules will be fine. Okay, as you can see, the protein can fit through the membrane, but still it can't pass because it's polar. And since it's a polar substance, the protein will bind to the water molecules. And since it binds to the water molecules, there are less free water molecules on this side. So osmosis must occur, and water molecules from this side will travel to the other side, creating an equal concentration yet again. Okay, here is a recap of everything you should have learned in this video. Diffusion is the flow of particles from a high to a low concentration. The osmosis is the diffusion of water. You should have learned the optimum settings for something to diffuse through a membrane, and when osmosis should occur. I hope this podcast has helped you. Thank you. Bye.